Remember the chain rule from derivatives where we had to take the derivative of the outside and then we multiply by the derivative of the inside? So now we got to do that with the antiderivative. So we're going to start with this first assignment, just identifying the inside function. You could probably guess already, instead of multiplying by the derivative of this inside function, we're probably going to divide by the derivative of the inside function. So what you could see right here, we're going to just define u basically. So what would u be? And you could picture, if you were taking the derivative of cosine or sine of this, right, derivative of the inside would be 6x squared. So what we're going to do with integrating, or taking the antiderivative, we're going to identify the inside function so that if we divide by its derivative, is it going to cancel out what had been created when finding the derivative by multiplying by the inside? Not sure if that makes sense. Let me see if I could just write it out real quick right here. Let's just say you're taking the derivative. Let's pick something simple like sine of x to the fourth. So let's just say we're finding its derivative. So the derivative of sine of x to the fourth would be 4x cubed times cosine of x to the fourth. Remember when we did the chain rule, derivative of sine is cosine, keep the inside the same, and then we would multiply by the derivative of the inside, which was just the 4x cubed. So if we're going to integrate 4x cubed cosine of x to the fourth, and I'm not going to go through this, but if we were to take the antiderivative of this, you know we're going to end up with sine of x to the fourth. And then, of course, plus c. But you know that's what we're going to end up with, because we just took the derivative of sine of x to the fourth and got this here. So we're going to have to identify, hey, what's the inside function? And if we divide by it, we'll cancel this out. Remember, because this is what got spit out when we did the chain rule. So let's start by just figuring out our inside function. Now, pay attention, because this is probably the hardest part, honestly, is picking that inside function. And this is one of those things where you may have the wrong choice, and you may go through the whole u substitution and find out that it did not work out. But if you remember from one of our previous assignments, let me see if I could find the right one. Was it this one? Yeah, it was this one. Your goal is just to try to match one of these here. You need it to perfectly match one of these here in order to take the antiderivative. If you can't do that, you can't take the antiderivative. So for example, you can't take the antiderivative x secant squared x. You can only take the antiderivative secant squared x, but you can't do it for x secant squared x. That won't work. So you need it to perfectly match one of those formulas on that list. So here we go. If I were to pick the inside function to our cosine, that's kind of a straightforward, hey, let's make that our u. That just makes sense, honestly. Pretty simple. So that's going to be our u. And if that was u, think about it. The derivative of this, what's the derivative of this? It's going to be 6x squared, which perfectly cancels out with that. We don't need the 6 to cancel. We need the x squared to cancel. Because the 6 we can always pull to the front of the integral and ignore it. But it's that x squared that can ruin things. So we're going to let u be the 2x cubed plus 1. On this one, we can't do the antiderivative of, that 2 can come out to the front. And we can have 1 over 2x minus 3. The problem is we need it to be 1 over x. So what if we were to make 2x minus 3? If we call it u, then our antiderivative would have just a u on the bottom, which we know would end up being natural log. If you find that back on that one list here, 1 over x, we could do 1 over x. That's fine. So I'm going to set u to be in this one is the 2x minus 3. Over here, if you look, an indicator, this is all being raised to the 5th power. So this is going to be the inside function. Also, derivative of 9x squared plus 4x is going to give you 18x plus 4. It's going to cancel that out. That would be the derivative of the inside. So u is pretty obviously, if you ever see an exponent, that's probably going to be your inside function. Just like right here, you may not see it right away. But if I rewrite it this way, that's cosine of x to the 7th power. You can see cosine of x is our u. Because the derivative cosine's negative sine, it would cancel out this right here. The negative's not the big deal. It's sine of x and u's to cancel out. Remember, the negative could just get placed in front of the integral sign. But since this is being raised to the 7th power, that's how you know that's going to be our u. Okay, there's no exponent here, but notice the inside of the sine function. That's usually an indicator also that's an inside function. So that's going to be our u. And you'll notice the derivative of this will give us what's here that will cancel that out. And last, once again, you see the exponent there. That's going to be our u. You see the exponent is to the 6th power. So natural log of x is going to be u. Because then it'll be u to the 6th power. And you'll see how that's going to cancel out that x on the bottom and make things kind of nice. So in the next assignments, we're going to go over how to actually do the u substitution for indefinite and definite integrals. Very, 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 very important lessons here. But defining u is foundational to this. It's going to be the anchor to the rest of these assignments.